Hello friends. So last lecture we have studied some basic points related with this graph. So now in today's lecture we will see what is self loop, what is a cut set. So self loop is an edge E if it has the same endpoint. So for example, suppose this is a vertex A, right? And this edge E. So this edge E is connected by two endpoints, that is A, comma A. Right? So starting point is also A and ending point is also A. So this edge is connected, right, with starting point A and ending point A. So this is a self loop. So edge connected to self that vertex, right? So isolated vertex. A vertex with degree 0 is called isolated vertex. So in last lecture we have studied pendant vertex, right? Whose degree is 1 is called as a pendant vertex. And a vertex with degree 0 is called as an isolated vertex. The cut set. Consider a graph G with set of vertices V and set of edges E. G equal to V comma E. Cut set for G is the smallest set of edges such that the removal of set disconnected the graph, whereas the removal of any proper subset of this set left a connected subgraph. So by removal of edges, disconnect the graph into two parts. So whatever cut set is there, so minimum set of that edges is nothing but the cut set. So for example, here this is the graph. Right? So for this graph, edge set v1 comma v5, v1 v5, this edge is a v, this one is a v1 and v5, this edge. By cutting this edge, right, and this one v7 and v5, this edge, whenever we cut this edge, right, so graph disconnect into two parts. So this is the smallest, this one is the smallest cut set. Again there is, whenever we cut this this also, again graph disconnect into two parts, that is v5 v6 and v5 v8. These are the two edges. So minimum cut set is here two edges. By cutting the two edges, disconnect the graph, right? Or we can say removal of these two edges, disconnect the graph. So this is nothing but the cut set. Also this one is also cut set, because graph again disconnect into two parts. This is v4, this vertex is one part and another remaining is your another subgraph, right? So next, cut points or cut vertices. So consider a graph. Cut the points are done by the cut points by cutting or removing that vertex, right? So whenever in cut points or cut vertex, whenever we remove that cut points or cut vertex, we have to remove whatever edges associated with that vertex. Same here, whenever we G minus V1. So when we remove this V1, next, when G minus V1 in figure 1. So whenever we remove this V1, so with remaining G minus V1 is this one. So whatever edges is associated with that vertex, right? So we have to remove that edges also. Here G minus V3, whatever edges associated with this V3, we have removed here, right? So this is G minus V3. Here G minus V5, right? In G minus V5, see, this is V5, V5 at the middle. So this 1, 2, 3, 4. 4 edges are associated with this one. So we have to remove this 4 edges, right? So after removing this 4 edges, so this will be a subgraph, that is G minus V5. Then bridge or cut edges. Consider the graph G is equal to V comma E. A bridge for graph G is an edge E such that G minus E has a more connected components than G or disconnected. So consider the graph, that is G, whenever we G minus E1 by cutting the edges, that is E1. So whenever we remove this E1, right? Whenever we remove this E1, so we will get this V1, we remove this edge E1. G minus E3, right? So this is your E3, right? This one is your E3. So this one is your E3, right? So when we remove this E3, we will get this graph G minus E3. So this is a bridge or a cut edges. Then types of a graph. So types of a graph. First, that is a null graph. A null graph is defined as a graph which consists only the isolated vertices. So we have already studied the isolated vertices or isolated vertex. What is the isolated vertex or vertices? The vertex whose degree is 0 is called as isolated vertices. And in null graph, which consists of these isolated vertices. So for example, see here, this one. So this V1 whose degree is 0, this V2 whose degree is 0, this V4 whose degree is 0, here V5 whose degree is 0, again V3 whose degree is 0. So this is nothing but the null graph which consists of only the isolated vertices. So isolated vertices, that is, whose degrees are 0. Next, undirected graph. And a graph, undirected graph G consists of a set of vertices V and set of edges E. The edge set contain an unordered pair of vertices. If this U comma V belongs to E, then we say that U and V are connected by an edge, where U and V are vertices in set V. Undirected graph means what? For edges, there is no direction for that, the edges. And in multigraph, if in a graph multiple edges between the same set of vertices are allowed, it is known as a multigraph. In other words, it is a graph having at least one loop or a multiple edges. So that is, we can say, suppose this one is your graph, right? 1, 2, 3, and 4. That's the 4 vertices, right? So what is the definition of multigraph? The graph having at least one loop. One loop means what? This one, right? Loop. Or a multiple edges. Multiple edges means what? There is a parallel edges. So the one edge adjacent to 4 by 2 edges. This one and this one. So these two edges are, that is, suppose this is the E1 and this one is your E2. So this E1 and E2 are the parallel edges. So these two vertices are connected with each other by multiple edges. So the graph having at least one, two, or a multiple edges is called as a multigraph. Directed graph, a graph having, or a digraph G is defined as the unordered pair V comma V, where V is a set of points called vertices and E is a set of edges. So edge in the graph G assign a directions and is identified with the ordered pair U comma V, where U is the initial vertex and V is the end vertex. So directed graph means what? Same here. So this is your graph, right? So there is A, B, C, and D. So generally, whatever the pairs are there, ordered pairs are there, that pairs containing some directions, right? That edge containing the directions like this. So this is your directed graph. Directed graph. That is unordered pair V comma E, where V is a set of points and vertices, where E is a set of edges. So that is the every edge have assigned some directions. Nothing but your directed graph. So okay, we'll stop here. Next session, we'll see the remaining points of this graph.